Okay, so the answer here is the 0.61. 80, and then 22%, it will be 61.80%. And then the part C. Okay, so part C, it's in between those two rainfall, right? Okay, so first of all, let's draw the bell curve. For the bell curve, the mean in the center is 40.23. So the smaller rainfall is x equal 37. The bigger one is x equal to 41. And we want an area in between. So first of all, you take the bigger x values, right? So taking x equal to 41, and the mean is 40.3. Sigma is 6. And we can find out the z-score. X minus mu over sigma 41 minus 40.3 divided by 6. Then let's go to the Excel. Get the result. 41 minus 40.3 by 6. So this turned out to be 0.12. So the biggest z-score is 0.12. And then we're going to also find out the z-score corresponds to smaller smaller x values, x equal 37, mean is 40.3, sigma 6. Z-score is minus mu over sigma. One more time. 37 minus 40.3 and divided by 6. Let's see what that is. -37 minus 30.3 by 6. So it's negative 0.55. So the smaller z-score is negative 0.55. All right, so now first of all, we're going to look up the bigger z-score first for the bigger probability. 0.12, 0.12. So the bigger probability is 0.5478. So 0.5478. And we're going to take also find the area corresponds to the smaller z-score, negative 0.55. Negative 0.55. 0.55. So this turned out to be 0.2912. 0.2912, and the difference is the answer, 0.292. We subtracted with a 6, 5 to 0.2566. So the answer is 0.2566. Meaning the percentage will be 25.66%. Okay. So that's the third part, right? So that's the area in between. So this question actually covers all three different scenarios here. It's question 2. Question 3. So we have still a normal distribution, but we're going to apply the central limit theorem in this example here. Because there's a randomly selected sample. So we have a randomly selected sample, purchase sample of 10 items. That gives us central limit theorem. So first of all, we know the mean. Mean is 2.5 years. And the standard deviation, 0.6 years. And then we have a sample size of 10 items. Sample size equal 10. We want to find out the probability of average life will be longer than 2 years. So first of all, you draw the bell curve. Put down the mean, 2.5. Population mean. And then this sample mean here, this is what we call sample mean, 2 years. Sample mean that's 2. We're comparing the sample mean to the population mean. And because it's longer than 2 years, that means we want area to the right. So do the conversion first. First of all, sample mean is 2. Population mean is 2.5. And sigma is 0.6. And also we have a sample size. Let's find out the z-score here. Z-score equal to sample mean minus population mean over population standard deviation over square root of sample size. So right here we have 2 minus 2.5 over 0.6 over square root of.
Professor.
Yes.
I can't see what you're doing.
Oh, okay. I forgot to share probably. How about now? Can you see it?
Yeah, now it's fine. Thank you.
Okay. Sorry, I forgot to share the screen. Yes. So here the mean is 2.5 standard deviation, sample size is 10, and then we have sample mean here. So you draw the bell curve, and then we figure out we want an area to the right. That's what we're looking for. So we use the z-score formula on central limit theorem. Central limit theorem applied here. So z-score equal 2 minus 2.5 over 0.6 over square root of 10. So now let's go to the Excel. So now put in equal sign 2 minus 2.5 over, put a denominator in the parentheses, 0.6 over square root of 10. And that's a problem equal. Make sure you put both numerator and denominator in the parentheses. And then the answer turned out to be negative 2.64. Negative 2.64. So that means this z-score is negative 2.6. Now, based on that z-score, we will find the area to the left. So find this area right here on the table A2. Negative 2.64. Negative 2.6. So the area to the left turned out to be 0.0041. 0.0041, that's the area to the left. But we want an area to the right. So it will be 1 minus area to the left. So this turned out to be 0.995. The answer here is 0.995. Any question about this? 959. Check it, it's good, right? And let's look at the question 4. Question number 4, we're still going to apply the central limit theorem because we have sample here with 25 roots. Let's go to that. So first of all, you will draw so it's normally distributed, and then the mean is population mean, right? That's 639. The standard deviation sigma is 18. So you first of all draw the bell curve, put a population mean, and then here they pick 25 roots, and then they want to find out the probability that average weight is between 636 and 643. So 636 is on the left hand side, and then 643 is on the right hand side. So again, they want to average in between. And that's a two-step. Right? First step is find out the z-score for the bigger average weight. So bigger average weight is 643. Population mean is 639. Sigma is 18. And we know sample size is 25. So based on those 4 things, we will be able to find out the z-score. Sample mean minus population mean, top over population standard deviation over square root sample size. So 643 minus 639 goes on top over 18 by square root of 25. And now that's the first one. Let's find out z-score here. Will be 643 minus 639 over open parentheses 18 over square root of 25. Square root of 25 is 5. I'm going to just use the simple answers. That's okay. And yeah, let me double check the inputs. Yeah, it's good. And that should give you the result, by the way, right? It's 1.11. 1.11, that's 2 decimal place. That's what we want. So the bigger z-score here is 1.11. So let's take a look at the smaller z-score. For the smaller average weight, so sample mean here is 636. Same thing here is 639. Sigma is 18. Sample size 25. So the z-score equal to sample mean minus population mean over population standard deviation over square root sample size. So 636 minus 639 over 18 by square root of 25. And let's see what our z-score is. (636) minus 639 over 18 by square root of 25. And, let's see, this could be a negative numbers. See what that is, negative 0.83. Negative 0.83. Now, basically, we look up the probability for the bigger z-score first. 1.11 from table A2. Second page, 1.11. And the probability is 0.8665. 0.8665. using a bigger probability minus the smaller probability corresponds with the z-score of negative 0.83. Negative 0.83. The corresponding probability is 0.2033. And the difference is the answer, 0.2033. 0.033. And the difference is the answer. That's area between 2, 3, 6, 0.6632. The answer is 0.6632. Any question about this? Yep, so it's the correct answer. Okay. So we're going to move on to question 5. In question 5, we have a confidence interval already expressed in the plus minus sign, but you want to turn into the confidence in interval form. So basically, you just need to do a quick conversion here. But they want decimal forms, right? So first of all, we're going to convert this to decimal. 81.5% is 0.815. Plus minus 5.6%, that's 0.056. And for in the interval form, that will be 0.815 minus 0.056, that's left-hand side, and 0.815 plus 0.056, that's right-hand side. And we're going to get the following form. 0.815 is 957, so 0.759. And then on the right-hand side, when you're adding them, you're going to get a 0.871. That means that's what they want. 0.759 on the left, 0.871 on the right. This is what they call an interval form. So this is going to be open parentheses 0.759, and put in the other one 0.871. So let's do it. Yep, so the answer is good. Okay, any question about this? Now let's look at question 6. Question 6, it's a confidence interval question, right? Because if you look at the result here, you want to find out lower limit to estimate the population mean and an upper limit for the population mean. So let me share the screen with you first. Here we go. So first of all, when you read through the questions, let's put a symbol for each number here. So you measure 28 pascal in the sample size. So the mean weight, meaning the average weight, population mean is 71 ounces. Assuming the population standard deviation sigma is 14.8. Then construct a 99% confidence interval. So 99% confidence, we know that because sigma is given, so we are using the critical z-score. And the 99% is 2.575. You don't have to memorize this. You can just look it up really quickly from the table A2. If you scroll down to the second page of table A2, to 99% confidence level, the critical z-score is 2.575. So get it from there. Now we're going to apply the margin error formula. Margin error equal to critical z-score times population standard deviation over square root of sample size. We know all three of them. Sample size population standard deviation, critical z-score. So throwing into the formula, we get 2.575 times 14.8 over square root of 28. And I'm going to run it to two places, right? Two decimal places. Go back here. 2.575 times 14.8 over square root 28. Yeah, and then that should give us a margin error. So in this case, margin error will be 7.20. If I need to do decimal place, that's what I want. Is 7.20. Now, once we have the margin error, we know the sample mean. We know that this is actually the sample mean. Sample mean is given. Because it's 28 Haskell, so we are given the sample mean, not population mean. We are estimating the population mean. So lower limit will be sample mean minus margin error. And upper limit will be sample mean plus margin error. So it's going to be 71 minus 7.20 on the left hand side, 71 plus 7.20 on the right hand side. 71 minus 7.20, that will be 63.80. The right hand side will be 78. So come up with the confidence interval here. Any question about this? 63.80, 78.20. Yep, good answer. Yep. So question 7, it's a very similar one, but probably with a slightly different outcome, right? Because the outcome here you only need a sample mean and also margin error, but you put it separately in this case. Okay, share the screen first. So again, imagine 44 backpacks. That means sample size is 44. And then average mean for those 42 for those 44 backpacks will be 42 ounces. So sample mean here is 42 ounces. And assuming population standard deviation is given, population standard deviation is still 14.8. And we construct a 90% confidence interval because the population standard deviation is given, so using a critical z-score, 90% critical z-score is 1.645. Now one more time, you're going to use that to find the margin error. First, critical z-score and population standard deviation over square root of sample size. So it's 1.645 times 14.8 over square root of 44. And again, two places, we're gonna turn into two decimal places. One more time, so it's gonna be 1.645 times 14.8 over square root of 44 in this case. Once we put it in the proper form, we enter, we get a result, two decimal place. So this is 3.67. That's a margin error. So margin error is 3.67. And then here you just need to put sample mean plus minus margin error. Sample mean goes in the first box, which is 42 ounces, plus minus 3.67. So this is actually slightly easier compared to the. Any question about this? $42 and 3.6.
Professor, I have a question.
Definitely.
Is this question like the last one where you just have to subtract it and then add it?
No,
To
this
find
you
both?
don't. Oh yeah, and this one you don't need to subtract them. You see, we only want a plus minus sign, so they want to sample mean and then margin error separately. Does that make sense?
No. What do you mean? I didn't see how you got 42.
42 is given here, right? Sample mean is 42. The question tells us the sample mean is 42 for those 44 bad types. And so, and there are 3 different ways to put in the confidence interval, right? One way is to sample mean plus minus margin error. That's what they want here. You can also do second one, right? Sample mean minus margin error, sample mean plus margin error, right? But you can put it this way: population mean is greater than sample mean minus margin error, less than sample mean plus margin error. The previous question is based on this, but this question only did this, right? That's why you don't need to add a subtract.
Okay, so then, okay, I got it. Thank you, Professor.
Okay, no problem. Yes. Okay, that'd be good for question 7. But that's very good question. You know that the answer they put is in a different form, so just be careful. Sometimes it could be tricky. Question 7. Question 8. All right. So let me just first of all put this in another form. All right. So now in this question, we are given pretty much all the numbers needed. So we know the sample size in the symbolic form. We know the p-hat. So definitely we are estimating the population proportion. P is population proportion. And it's a 99% confidence. So that means critical z-score is 2.57. So basically we have all of these numbers we need. And since we know p-hat, then we know q-hat. Q-hat is 1 minus p-hat. 1 minus 0.61, 39.39. And if you quickly look up the formulas from the formula sheet. So this is the margin error formula we are using here, right? This is the one. We're going to take this, get a margin error first, and then add and subtracting from left and right, get a result. So margin error equal to critical z-score times square root of p-hat times q-hat over sample size. It's a 2.575 times square root of 0.61 times 0.39 over 590. Sample size is 590. And we're going to get a margin error here. So let me just quickly show you how to get it done in Excel. So put equal sign first, 2.575 multiplied by square root of 0.61 times 0.39 by 590. And this is the proper input, right? Make sure you put the product and quotient inside of the parentheses. It's under 1 square root to get a proper answer. Okay, then hit enter, you get a result. Let me see how many decimal they want. 3 decimal places. It's that here, 3 decimal. So you're going to run it to 3 decimal place. So that will be 0.052. That's 3 decimal place. So here margin error is 0.02. This one we will do p hat minus margin error, but inequality, yeah, and p hat plus margin error. So p hat, we know that it's 0.61. So we do 0.61 minus 0.052 the left, the right is 0.61, adding 0.052. And if you subtract those numbers, you get 0.558 on the left, and then on the right, combine them, you get 0.662. And that's what they want, right? Point number 8, 0.662. All right, any question about this? So you're just going to put 0.558, 0.662. On the left hand side and the right hand side. Yep. Any question? Yep, it's good. Right. So the answer is good. And that is question 8. Let's look at question 9. And this one is how many students? When you see the keyword, how many students? That means we are estimating for the sample size. So let me just first of all copy the question. Yeah, share the screen. So first of all, we have a mean, although it's given here, but it's not needed. So we don't need the mean here. It's given the sample mean, right? As population mean. But we don't need it. And then we know the population standard deviation, right? That's, this is a general statement saying that the mean of all the SAT scores is 1500. And standard deviation for all SAT scores is 300. Sigma is 300. And you're interested in estimating the average SAT score of first year college students at your college. If you would like to limit the margin error to 25 points. So margin error must be 25 points. The margin error is 25 points. And then it's a 95% confidence. That means a critical Z score must be 1.96. Now we know this, we know margin error 25, then we can find our sample size. Now one more time, we're going to go to the formula sheet, right? Find it. And we're going to use this one because it's a mean, right? It's about mean. So the formula we are using is a third formula. So critical Z score times population standard deviation over margin error. I'll square that afterwards. So this is going to be square bracket critical Z score times population standard deviation over margin error. Square that. We're throwing out the numbers 1.96 times sigma is 300 by 25. After that we square it. And we're going to get the decimal answers. You'll see in a second. So if you put into the Excel, it's going to be open parentheses 1.96 times 300 over 25. And then we're going to square it. Raise the second power, square that. And you see we get a 553.1904. So that's the answer, 553.19. And the running rule here is we always run up to next whole numbers, no matter what, right? So the answer is always going to be more safe or to be more conservative. The bigger the sample size, the better it is, the better your result is. So that's what always run up to the next whole number. So in this case, it will be 554 in terms of the answer. So this is amount of students you will need to survey in order to guarantee margin error is 25 points with a 95% confidence. I checked it. So it's good. The answer is good. Any question about question 9? All right, let's look at question 10.
So,
Right, question.
I have a question.
Sure, definitely. Go
We
ahead.
always round it to the next whole number, right?
Yes, exactly. Yeah. Next whole number. Yeah. Always, right? No matter what decimal you have. Next whole number.
Professor, I had a question too.
Sure, definitely.
Okay, so
This side, yeah.
for the confidence interval problems, how do you get the number, like the decimal that you put? I think it was 1.96. How did you get that?
Oh, you mean the critical z-score, right?
Okay.
Yeah. Critical z-score, you will find it from here. You see all the common critical values. If you go to the table A2 on the second page, there's like a little table here.
So
with
we
all
look at
those-
the last two numbers on the right or the second last?
Yes, so based on the confidence level, if it is 90%, then the critical z-score is 1.645. If it is 95%, then it's 1.96.
Oh, okay, I see now. Okay,
And
makes sense.
99% is
Okay,
2.575.
okay, says it, okay.
Very good. Right, so that's how you get 1.96 here.
Okay, thank you.
No problem. All right, so now let's go back to the next question. Next question is fairly quick question. So we know an alternate hypothesis below, right? Now hypothesis is population mean equals 31. Alternate hypothesis is population mean less than 31. What type of test is this? So the alternative hypothesis determines the type of test, right? If it's less than, it's left tail. If it's greater than, right tail. If it's not equal to, two tails. So three different type of tests. And it all depends on the alternative hypothesis, right? In this case, is less than, so left tail. So left tail test. In this case. And question 11. So we are given this statement. Average weight of male dancers in the local modern dance company is more than 174 pounds. This is one of the claims, right? And this claim, its population mean is more than 174 pounds. And that cannot be a null hypothesis because there's no equal sign here. And then, so that has to be an alternative hypothesis. Alternative hypothesis is mu greater than 174 pounds, right? And then the null hypothesis will be B. You can do either one of these. You can do equal to 174. That's okay. If you take it, this is perfect. You can do greater equal to, right? No, less equal to. That's okay. Yeah, either one of these. As soon as the alternative hypothesis is mu greater than 174, the other two will be okay. Right. Any question about this? That's 11. Question 12. So we have a scatter plot here for a set of the bivariate data, meaning it's a scatter plot. And you want to find out what would you estimate the correlation coefficient, right? If you look at this, it looks like a random plot, right? There's no clear pattern here. There's no linear relationship appearing in this data set, right, in terms of the graphical presentation. So that means it probably is 0, right? There's no, it's a random plot. So the correlation coefficient, there's no relationship between those two variables. So the answer is 0. All right, any question about it? Question 12. And let's look at the question 13. Starting on question 13, you need some calculations. Okay, I'm going to show you guys. So for question 13, we want to find out the linear regression, right? To find the equation for linear function that does fit the data, right? That means we're going to need to use the formulas, B0, B1 formula from chapter 10. So you're going to need to find out B0 using this formula here, and also B1 using this formula. And let's, first of all, we need to do some prep work, meaning we need to prepare all the items first. So we're gonna just copy this. Right? Then if you see highlight in blue, right click on it, you're gonna see copy that. Now you're gonna go to Excel, and you put in this another sheet here. And you're gonna paste it here. Okay, and paste it like that. That means we already get a data set settled down here. We need 3 columns, right? X times Y, X squared, and Y squared. So let me format it really quickly. Put into the 10 size. And then put body. And then center base, all borders.
Professor,
then-
we cannot see what you're
Oh,
doing.
okay.
Can
Okay,
you share?
sure. Can you see it now?
Yeah.
Okay. So first of all, just like what I did, we pasted the data set here, create 3 columns, and then we're gonna put in create all those columns, and then first of all we calculate X times Y, X times Y. So B2 times C2, and we get this number here. 1 times 812 is 812. And then you can just drag it right all the way to the bottom to get the rest of them. Excel will follow the same formula here, see, to do the calculation. We also need a X squared, right? So we're going to square this number here. Square the B2. You get 1. 1 square is 1, right? The 2 square is 4. 3 square 9. All of those, you get all of these numbers. 6 square 36. Now we also know what square of Y. Y square C2 square. Get that, and get the rest of it. And we also need a total, right? So total, that's very important. All the calculations based on total. So now let's get the total of X. We see this summation sign, auto sign, that total of Y, that total of XY, get this, total of X squared, get this, and total of Y squared. Yeah. So we get all the numbers. The next thing I'm gonna format it, and the next thing I'm gonna just write it. Right? So it's gonna be this total of X is 21. Total Y is 5065. Use it smaller. And then total of XY. Give me a second. Let me quickly modify a little bit. The color smaller size. Total of XY is 17896. Total of X squared is 91. Total of Y squared is 4281379. So we have all the numbers now. First of all, we're going to find out the B0. So the B0 formula. So those are the numbers we need put into the formula. Now B0 formula is N as total of Y. You get it from the formula sheet. Total of X squared minus total of X times total of XY over N times, you can put in the parentheses if you want to, N times total of x squared minus total of x plus t squared. And one more time, I'm going to throw in all the numbers. So this one is 5065 times total of x squared, that's 91, minus total of x, 21, times total of xy, 17896. That's on top, on the bottom. So if you look at it, the sample size here, we have 1, 2, 3, 4, 5, 6, right? 6 numbers here, 6 order pairs. So the sample size in this case is 36 times total of x squared 91 minus total of x 21 square that. Now you can put into the one of the cells, right, to calculate this B0 here. Put it underneath here. So you're going to do 5065 multiplied by 91 minus 21 times 17,896. That's numerator divided by denominator is 6 times 91 minus 21 squared. And that will do it. We're going to get this 810.4667. So that's the answer, 810.4667. So that's how you find out the B0. You also need to find out the B1. I guess I'll put a B1 on the side. So the B1 equal to n times total of x1 minus total of x times total of y. Top on the bottom is n times total of x squared minus total of x squared square that. Now one more time, I'm going to throw in all the numbers. 6 times total of xy, 17,896. And minus total x is 21, the y 5065 over sample size 6 and total x squared 91 minus total x 21 square that. All right. Now one more time, let me put it on the side. So I'm going to calculate it here. Equal to 6 times 1789 minus 21 times 5065. Those parentheses and divide by sample size 6 times 91 minus 21 squared. All right, that will do it. To enter the result, that's 9.62357. You don't have to write so many decimals. I think they have a running rules available there. You see how many decimal they want. 2 decimal places. So that means B0 is going to be 801.47. And then the B1 is going to be 9.63. And then our regression model to be predicted value equal to B0 plus 1. So that should be B0, that's 810.47, adding 163 times x. That's all we need, right? That's all we need. We're going to put that into the answer box. So 810.47, adding 9.63 times x. Right, that will do it. And then check it. Now it's perfect. Any question about this? So you guys, yeah, if you guys need this spreadsheet, I can save it. I will email it to you later, right? When we finish the review section, let me just save this here. PC. Exam review spreadsheet. You guys can look over this if you want to. Here, notes. All right, so we're gonna move on to question. This is question 13, right? Let's move on to next question, question 14. Question 14, still we get a data set, a big data set. And we also want to find out the correlation coefficient R, right? So one more time, the under what formula we are using this formula here. N times total of xy minus total x minus total y over 2 square root on the bottom. Okay. And first of all, we need to set up the table. And also, so you highlight the entire table. And right click on it, you're going to see copy. Click on copy. Now go to Excel spreadsheet, right? I'm going to put it on a new sheet. I paste it here. You're going to see all of this come up. And let me just format this really quickly. 40 and I'll be 12. Maybe let's put in 16, 14. So x times y, x squared, y squared. And we're going to put in all orders. And one more time, we're going to do the calculation one by one really quickly. And you can see all the pairs here 1, 2, 3, 4, 5, 6, 7.
Professor, we cannot see it.
Okay. Yeah, I forgot to show.
Sorry.
How about now? It's good, right?
Yeah.
Okay, very good. So it's a similar prep work. The table is needed. So transfer into the Excel is so much easier. First of all, you multiply the x is the y. Okay. And hit enter, right? You get the product of those two. And then once you do one of them, you see put a green box here, put a cursor on the bottom right hand corner. And you see that solid plus sign and drag it. You get the rest of them very quickly. Okay. That numbers. And also x squared, same thing. Square the B2. Now, similarly, green box, put a cursor on the bottom right hand corner, drag it. Get the rest of them. Very similar to y squared. Square the C2. Okay. And get the first number. And again, drag it. Green solid cross right there. That's when you can drag it. Drag it down all the way to the bottom. Okay, we get the rest of the numbers. Now, one more time, we're going to get total, right? About x. Highlight the entire data set, right? Excluding the title. Click on the auto sum here. Get the total. Same thing for the y. Highlight it on numbers. Auto sum the total. Highlight all the product. Auto sum. Highlight all the x squares. Get an auto sum. Highlight all the y squares. Get that. So you get all the total here. And we're gonna, yeah. So if you want to rewrite this, right? So we just rewrite it. So We know total of x is 72. We know total of y 871. We know total of xy is 7133. Total of x squared 636. So y squared 84,776. Now let's write down the formula for the r. Right? Okay, let's see. So the r equal to n times total of xy times total of x times total of y. That's on the top. On the bottom, so first square root n times total of x squared minus total of x squared. The second one is n times total of y squared minus total of y squared. So all you have to do is copy all those numbers on top. So on the sample size here, we just earlier we counted, right? Have a 2, 4, 6, 8, 9. Sample size is 9. Now all the numbers go into the formula. So that 9 times total xy 7133. 7133 minus total x 72 and total y 871. That's on the top. On the bottom, so usually we will put in a big parentheses here. Big parentheses. The first square root is 9 times total x squared is 636 minus 72 squared. That's first parentheses square root. Second square root 9 times total y squared 84776 minus total y 871 square root. Now I'm gonna put it on the side, right, to show you complete calculation part here. So equal to open parentheses, which maybe slightly bigger. Up here, okay. Equal to, right? Open parentheses, 9 times 7133 minus 72 times 871. And that's a numerator divided by denominator open parentheses and that's square root, first square root. 9 times 636 minus 72 squared. And then take care of the first square root, second square root, SQRT. 9 is 84776 minus 871 squared. And then close parentheses. And then that should do it, right? That should be the answer. And then if you enter, you get 0.96969. This is 0.696. And based on the R, we know that it's a strong, very strong, direct correlation. Meaning the relationship is very strong and direct, meaning positive, right? Strong positive correlation. 0.96969. If you put it here, if you put in more decimal, that's okay. 0.96969. That's totally okay, right? It will take more decimals. No, there's 3 decimal. Okay, and 70. So actually, why is not? Okay, see 2, 4, 6, 7. Usually good. Go back here and let me see. 2, 4, 6, 7. Is there anything? Oh yeah, this one is 0.02. I probably should put in. I forget to resize this, so this number is slightly off, right? The total of y squared should be 84776.2. So 0.2 here. So it's 9 times this 0.2. I'm going to quickly redo this. Let's go back here. It's 71.2. I'm going to put back that 0.2. It's 76.2 minus 871 squared. I just have to go back here, change this a little bit. 0.2. And the good thing about using Excel is if you make a mistake somewhere, you can go back, quickly check this. So when you run to 3 decimal places, 96946. 6,946. So run into 3 decimal places with 0.969. 0.96946. And also, earlier I forget it, but it's good now. I forget to resize this. Remember, on the last one, without resizing, it look like it's A4776. After I resize it, right here, the decimal number comes up. Now we want to make sure it's accurate. You should use the exact numbers. Right? And just show you, if you forget to include exact numbers, your answer will be slightly off, which is not good. Right? You want to make sure all the numbers are accurate, especially for chapter 10. That's very crucial. So make sure if the number is large, resize it so you get the correct answer here. If you want to put in 3 decimal, that's okay, right? Correct answer, 0.961. Any question about 14? All right, and the 15 is very, very similar. We try to find out the, yes, let me just copy the data set one more time. So let's copy the data set. Yeah, copy. So let's right click on it, copy, and then go back to Excel, and share this time. Another sheet, I'm gonna open another sheet. Similarly, we get the X and Y. We need 3 more cells. We format that really quickly. Put in the borders, center, bold it. Put in the font size, say 12. We need X times Y, very similar, X squared, Y squared. And we need a total element. That's the most important thing. So let's get XY first. X times Y. Get that. I'm going to get the rest of them. Same thing for X squared, squared X. I'm going to drag it, get the rest of them. Same thing for the Y squared. Squared C2. Drag it. I'm going to make this a little bit longer because this one has a decimal, so it probably needs more space. So make sure that once you have the numbers, resize a little bit, and you can just drag it, resize it. And let's get total of X, 27, which should be good. But Y, 334. Total XY is 1533.4. Total X squared, 139. Total Y squared, and that now is has a 2 decimal here. So resizing does help a little bit. We don't skip all those decimals. Now same thing, I'm going to format this center 14 here. So we're using 14. Now let's get the summarized. Total X 7 and total Y is 334. Total of XY 1, 2, 3, 4. This is total of x squared, 139. Total of y squared, 18666.88. Now apply the formula, right? Same formula, our formula equal to n times total of xy minus total of x times total of y. I take out the numerator, the denominator. First square root is n times total of x squared minus total of x squared. First one, second one is n times total of y squared minus total of y, so this is square. Now from here, we're gonna throw in all the numbers, right? Again, the sample size here, 1, 2, 3, 4, 5, 6, right? 6 numbers. 6 numbers here. So sample size equals 6. That's awesome. Now just so all the numbers go into the different color here. So it's going to be it's going to be 6 times so xy 1533.4 minus total x 27 and total y 334. That will go in a numerator. And denominator first parentheses 6 times first square root 6 times total x squared 139 minus total x 27 square root. Second square root open parentheses 6 times total y squared 18666.88 minus total y 334 square root. Close parentheses. And one more time, we're gonna go into the Excel, right? So that Excel do the calculation 6 times 1533.4 minus 27 times 334. Close parentheses divided by open parentheses first square root of 6 times 139 minus 27 squared. Multiply by second square root of 6 times 18666 minus 334 squared. And of course, another parentheses. Yes, so the answer cannot be 0.8436. 0.8436. But again, how many decimal they want? 0.8436. Pretty good. 3 decimal, but we can put in 4 decimal. 84. Yeah, I will do it. Right? It's good. If you want to put in 3 decimal, 0.844. That should be good as well. All right. So that's basically the how you calculate the R in Excel. So to show you both ways. You want to do it by hand, just like what I did here. I did it by hand. But you can use the Excel to get the results, right? It's so much easier. Or if you want, you can do one thing at a time. If you did it in a calculator, you can get an answer for the numerator first, get answer for this part first, and then get answer for the other part, and then do it step by step. No problem. But make sure you do not run, right? Not too much running. Keep as many decimal as possible. So your final result will be accurate. All right, and that's pretty much everything on the review sheet. I think it's better this way, so I can record a section, so you guys can go back home. When you prepare for the actual final, you can use this video. When I finish producing, I will email to you guys, so you guys can use it to study for the actual final. Okay.
So Professor,
Sure. Yeah.
Can you do number one or it's gonna be posted on Blackboard?
You
Because I was-
mean that, yes, I will post the entire, all of this, in our book. I mean, I will send it to you. I will produce the video first, right?
Mhm.
And I will email it to you and also post it now for the workforce. Later, yeah, when we end the section, I will start producing this. I probably will get it done tonight, and then I will email it to you guys. Okay, but we still have some time, so if you guys have any questions on your homework assignments, I'm more than happy to help you out. Any like individual questions?
Professor, I have a question.
Sure, yeah.
So is it, do you know how many questions we're gonna have for the actual final? Is it 15 or is it more than that?
It's 15, yes,
Oh,
for sure,
okay.
right? Yeah, so whatever you see here, if you can do this review sheet without problem, you're ready for the actual final, right? No surprise. All the questions will look
Okay,
very similar.
okay, with just different numbers, of course.
Yeah,
Okay.
definitely, that's right.
Okay.
Yeah, slightly different.
And when is it gonna be available, the final?
You're gonna take it next Thursday, right? During the class time, so I will send you guys a Zoom meeting link for next Thursday. And then I will make it available during the class hours. So you take it just like you come into the class, right? But you stay home and then during the Zoom meeting,
so-
you guys can take it next Thursday.
Okay, so it would be the duration of the class.
Yeah,
time,
duration of
which
the
is like
class
an
time.
hour.
An hour and 40 minutes. You
Okay,
see, I did all the questions, right? And also I explained to you guys, you see, I didn't even spend 100 minutes. I only spent like 90 minutes. So it definitely have more than enough time. But if you need,
Yeah.
let's say another 5-10 minutes, no problem. I can accommodate that.
okay,
Yep, for sure. Yeah.
thank you, Professor.
No problem. Yeah. Anybody
Professor,
else
can
have a
we do
question?
number one again, please?
Number one.
Mhm.
The thing is, I will remember I did this earlier, but I guess I can redo it. Just, it will be recorded though. You're gonna get this video, right? As soon as we end a section,
Oh,
I'll
okay,
produce it.
okay.
I emailed it to you, and then you can review the whole from question 1 all the way to question 15. No problem. So but yeah, if you can stay, if you want me to go over any questions in particular, you can stay. You know, we still have like another 10 minutes. I will answer that questions.
Professor, I had a question about question 4.
Okay, sure thing. You mean on the review sheets, right? Yeah, sure.
So I was confused about the z-score table. Like when you got the z-score from the z-score table after looking at, I think it was -0.5. And then I looked at the z-score table. I was just confused on which number to look at to know like this is the right answer.
Okay, no problem. Let me find that question, and I'll explain it to you. I didn't save it. Let me see. Finish the one. No, this is not the one. Okay. Okay, no problem. I guess I will do this. Redo this question. New. So you're not clear about how we get those probabilities, right, from table A2. Is that what you're asking?
Yeah, I
Okay,
wasn't like, how you looked at the z-score for like when you got the decimal and then you pick the number from there. That's what I was confused about.
Okay, I see. So again, the mean goes in the center, right? Now two numbers, one on the left, 36, one on the right, 643. I'm going to area in between. First of all, for the bigger x as the average weight, we find the z-score. So it is 643 minus 639 over. You're following so far, right, Afisa?
Yes, yes, I am.
Okay, so 18 over square root of 25. Now remember, we get the z-score for this one. And I still have the numbers in Excel sheet. Let's go back. Number here is, let's see, this one, and this one. Oh, this one. Yeah, this is the one. Okay, so we get 1.11, right? That's for the bigger z-score. So go back, this is 1.1. And for smaller average weight, 636, the z-score is 36 minus 639 over 18 by radical 25.
Okay, and
This-
to find the 1.11, right? We just type in like 643 minus 639
Yeah.
like that on
Mhm.
Excel, and it
Yeah,
just does it
that's
for
right.
us after we press enter.
Yes, exactly.
Okay, if
That's
we just
how-
type in like exactly like that, and it just solves it over there, right?
Yes, you get it. Yeah, so you get the result. Same thing for the other one, right?
Mhm.
39 in the parentheses over 18 or so of 25.
Mhm.
We get negative 0.83.
Mhm.
So now go back here, negative 0.83. Now you're gonna look up the bigger z-score first from table A2. We go to let's go to table A2 really quickly. 1.11. We go to the second page of the table A2. 1.11. We're gonna get 0.8665.
Okay, so that's what I had question about. So
Mhm.
1.1, right? How do we know for sure that it's a 0.8665? Like, how do you know it's that number? Because there's like so many numbers within 1.1. So how do we know which one to look?
Because the second decimal is 1.
Okay.
Yeah, so first decimal is 1. That's understandable.
Mhm.
And then second decimal 1, they have intercept. That
Okay.
intercept gives us the probability here.
Okay. So we look at what the second decimal is, right? On top.
Exactly. That's
Okay.
right. On top, there's a second decimal.
If it was 1.2, we would be looking at 0.02.
Yes, so it'll be
Okay.
0.8686.
Okay. Yes, that makes sense.
Okay. Now we get 1.11, 0.8665. They're using 0.8665
Mhm.
minus, we're gonna look up the probability associated with smaller z-score, negative 0.83. So let's see what that is, negative 0.83. And that should give us, let's see, 0.2033.
Yes. Okay.
Yeah.
0.2033. Okay.
That's exactly. So 0.2033. And then difference is the answer. Difference is area in between.
Okay.
And that's what we're looking for. So 3, 2, 3, 6, 6632.
Okay.
That's what that is.
Okay, that makes sense now. And
Okay.
Professor, everything is gonna be posted, right? Like the whole Zoom meeting, it's gonna
Yeah,
be
yes.
posted
I
on
will email it
Blackboard.
to you. I probably will turn into YouTube video.
Okay,
I'll
and
put it
even
in my
this
YouTube
part,
channel.
like what you just explained it to me, that's also gonna be there, right?
Yeah, totally. You'll be there. It's still recording right now.
Okay, that makes sense. Okay,
You'll be
thank you
there.
so
Yeah,
much.
for sure. No problem. Yeah, anybody else have a question before we end the section? So, okay. No questions? All right. Yeah, so in that case, I will end the section right here. I will send you guys a Zoom meeting for the final exam next Thursday, right? May 18th. You have a week to study for the final. I will send it next week sometime, right? I will remind you, taking the final on the 18th. use this video to study, right? I will send it to you either by tonight or by tomorrow morning. As soon as I finish producing the video, I will email it to you. All right, so I will talk to you guys next Thursday.
Thank you, Professor.
No problem, guys. See you next Thursday.
Bye, Professor.
Bye bye.
Take care, Professor.
Take care, Adam. Yeah.